Welcome back one more time, Mr. Reniker here, and in this lesson we are going to focus on operations and scientific notation. So your primary objectives are going to be the four main operations: addition, subtraction, multiplication, and division. And you're going to be doing that with numbers that are written in scientific notation. Of course, there are some specific rules that go with those. The first says this. It says to add or subtract numbers written in scientific notation with the same power of 10, just add or subtract the factors. When the numbers have different powers of 10, first we have to rewrite the numbers so that they have the same power of 10. Let's take a look at what that means. So in example 1, we first see that they're asking us to find the sum, meaning add, or difference, meaning subtract. And we're still going to keep our answer in scientific notation, but we can see that we're asked to add 4.6 times 10 to the third power plus 8.72 times 10 to the third power. So it stands out to me that we have our powers of 10 with the same exponent, which simply means all we need to do first is add the two factors together. So we take 4.6 plus 8.72, and that actually gives you 13.32. Since we added things with the same power, we're going to keep this power, so times 10 to the third power. So far, that's really all there is to it. We took the two decimal values and added them up. Now, there will be some occasions where this will be the end of your problem. Everything will be done, but notice it did say write your answer in scientific notation. And is this in scientific notation? And unfortunately, the answer is no, because our factor is not between 0 and 10. So we are going to have to change a little something here. And of course, that something is going to be to take our decimal and make sure that it's after that first non-zero digit. So instead of 13.32, we do end up with 1.332. But then we have to ask ourselves, well, what should happen to the power if we had to move that decimal 1 point to the left? Well, like many things in mathematics, there has to be some kind of a balance. So I want you guys to imagine this. At first, in this step, we had a number in the tens place, 13 being in the tens place, and we took one of its place values away. Now the number is only 1.332 instead of 13.32. Since our factor lost an entire place value, we need to add that same number of place values to our exponent. So we only had 10 to the third power. Since we lost one in our factor, we're going to add it here to the power and end up with 10 to the fourth power. So when they have the same power of 10 to start, we're just going to add the decimal factors together and go from there. In part B, here you'll notice that we don't start off with the same power of 10. The first one is a -2, the second one being a -3. So we're going to have to take a different procedure. Really, there's nothing we can do until those exponents are the same. So we're going to have to think about how we can rewrite one of these at least so that we have the same power of 10. And now, to be honest, there are several different methods that you can use here. I'm going to show you one of them, but feel free to use other resources if this one doesn't work out how you want it to. And here's simply what I mean. I like to look at the exponents and find the one or pick the one that has the greater absolute value. So we've got -2, which has an absolute value of 2, and -3, which has an absolute value of 3. So obviously, -3 has the greater absolute value. So we're going to use that one, and we're going to rewrite that one to help us out. And the reason I picked that one is because I can break the -3 up into two separate powers so that one of them is a -2. Here's what will happen with that. What I can do is take 6.6 times 10 to the -2nd times 10 to the -1st. And that'll still represent the same thing. But now I have this little guy hanging out here that looks like the power that's in my other factor here. And while that got me one step closer, I still have this other power of 10 on the right, and that doesn't match the correct exponent. So we're going to have to do something with that to simplify, or at least rewrite the scenario. And I'm going to have to apply that 10 to the power of -1 to my factor out front. So if I take 6.6 times 10 to the -1, that negative exponent says I lose a place value. So instead of 6.6, I'm going to end up with 0.66. But I still get to keep the changed exponent of 10 to the negative second power. And that was kind of my goal the whole time, was saying, how can I take this first expression and rewrite it so that it will have the same power of 10 as my other factor up there. But since I have that now, I'm ready to go ahead and subtract, because 3.5 times 10 to the negative second power now matches the other power of 10. They both have 10 to the negative second power. I can go ahead and subtract both the decimal values. So 3.5 minus 0.66, which does give me 2.84 times 10 to the negative second power. Now, just like in our addition a second ago, you still need to ask yourself if this is written in scientific notation. My factor totally is. It's between 1 and 10. And the exponent on the power of 10 is an integer, so actually this time we do not have to rewrite things first. So the process of rewriting some of these powers of 10, it'll take some practice, but I'll go ahead and give you a couple you can do on your own before we move on to multiplication or division. So here's an extra addition and subtraction problem. Notice here that in number 1, we do have different powers of 10, and in number 2, the powers of 10 are the same. So you'll have to remember the different processes, or rewatch the different processes between them here. But go ahead and pause the video, take a few moments, and then you can take a look at your solutions right after. And here you are real quick. Number 1 ended up with a pretty interesting little scenario. We should have 8.20341 times 10 to the second power. And for number 2, you should have had 3.3 times 10 to the negative fifth. Next, we're going to go ahead and look at multiplication and division. Predictably, multiplication and division are a little bit more straightforward for many people. It says to multiply or divide numbers written in scientific notation. Multiply or divide the factors and powers of 10 separately. We'll see why in just a moment. So here in example 2, it says find 3 times 10 to the negative fifth power times 5 times 10 to the negative second power. We need to make sure we keep our answer in a scientific notation. But notice here that the only operation in question is multiplication. And because of properties we have learned and used and reused many times this year, we know that if all we have is multiplication, we're allowed to use the commutative and associative properties of multiplication to multiply things in any order and in any grouping that we decide is helpful to us. So what I'm actually going to do is regroup everything, putting the factors together in one grouping and the powers of 10 together in a different one. And instead of having 3 times 10 to the negative fifth power, I'm going to have 3 times 5. And I'll do the same kind of thing over here on the left. But again, the reason that I'm doing that is simply because I can, and it's going to make this scenario a lot more efficient for us. We'll go ahead and handle our groupings one at a time. 3 times 5, of course, is just 15. And then we have these powers of 10, but this goes back to our earlier work with what we do with the product of powers. So we have 10 to the negative fifth times 10 to the negative second. They both have the same base. So all we need to really do here is add the two exponents. Negative 5 plus negative 2 is negative 7. So we do get 10 to the negative seventh power. Of course, it says write it in scientific notation, and this factor is not scientific notation. We would have to put a decimal between it. In other words, we are going to take away one of these place values in 15 and make it 1.5. But if we have taken away the place value in the factor, we have to add one back in our power of 10. So we're going to add one here, and negative 7 plus 1 should be negative 6. We get 1.5 to the negative sixth power. So again, multiplication and division, much more straightforward. In essence, we're multiplying the factors, multiplying powers of 10 and simplifying, and the process of rewriting things like addition and subtraction aren't as complex. Lastly, we'll go ahead and divide numbers written in scientific notation as well, and make sure we keep them in that format when we're all done. But just like multiplication, we are going to borrow some of the same ideas from earlier work, and we're going to only divide the factors and divide the powers of 10 and see where that gets us. So we have a problem a little bit larger here. We're going to start by dividing the factors. Have a calculator ready. 1.25 divided by 6 is 0.25 times, and now we have these powers here, and we've already learned about finding the quotient of powers. It requires us to subtract our exponents here. So we get negative 8 minus 7, which is actually negative 15. So we end up with 10 to the negative 15th power. Of course, we would be all done if everything's in scientific notation, but yet again, this factor is not. We're going to have to go ahead and increase the placement of that decimal point or add an extra place value, so it becomes 2.5. But similar to what we have seen recently, my general rule of thumb is that if you've added something to the factor here, we have to take it away from or we do the inverse of that to our exponent, I should say. So if we added one place value to the factor, we're going to subtract one away here. Negative 15 minus one more is negative 16. And lo and behold, we end up with 2.5 times 10 to the negative 16th power. It is now in scientific notation. So learning when to rewrite things and when to just multiply factors and powers, that again will just come with some experience and some practice, of course. I'll give you a little bit of that now before you jump into the assignment. So go ahead and take a look at these 4 problems, take your time, and then unpause the video when you are ready to check your solutions. And here you are. Number 3 was 4.8 times 10 to the negative 4th. Number 4 was 2.1 times 10, I'm sorry, that's to the 8th power. Number 5 was 2 times 10 to the 12th. And number 6 was 2 times 10 to the negative 6th power. With these being new, you might have some extra questions. So again, please feel free, as always, to reach out to me via email with your extra questions. And otherwise, good luck on your assignment. And as always, I'll see you next time.